an example here. Let's say I want to solve 1 plus x squared y prime. Sorry, that should be a minus. I'm just going to make that a big thick minus. 2xy equals 0. So what I want to do is solve this differential equation. These are called basically separable differential equations because you can separate the x's from the y's, and your strategy on these every single time is going to be to get the y's on the left and the x's on the right, and each of these should be like at the end you should have your dx here, and on the end your dy here. So to solve a differential equation, you just need to keep repeating this to yourself. To solve a differential equation, I need to integrate both sides. I need to find the antiderivative. In order to find the antiderivative of both sides, you have got to just have y's on one side, x's on the other. So could you get the y's on the right and the x's on the left? Sure, doesn't matter. So that's what I need to do here. So the y prime, that's actually, if you remember, that's dy over dx. That's going to take care of the dy and dx at the end of each of them. And so I'm just going to rewrite this like that right now. So far everything's over here. So I need to move both all the y's on one side, x's on the other. All right, so any ideas of what I could do here to do that?
Add the 2xy over and then divide it by y.
Okay, very good. So you see this minus, you know you can add it to the other side, but then you're moving the y over. Okay, that's fine. So then you'll divide by the y. Okay, so we can do that. Let's just add it over there first. Maybe I'll divide by the y later. What can I do with that dy over dx, or that dx on the bottom then? Multiply by that. So first I added that, then I multiplied by that. All right, so then what I have left over here is 1 plus x squared dy. Should I leave that 1 plus x squared over here? Bring it over. What do I do to bring it over? Divide it. So I'm going to have to divide by 1 plus x squared. So what's the only thing left over here now? Dy. Okay, that's dy. Okay, so what should I do now? What? Divide both sides by y. So I'll be integrating dy over y equals the integral of dx over 1 plus x squared. That is what I need to integrate. All right, so what is the antiderivative of dy over y? Oh, I forgot the 2x. Okay, good. 2x dx. Thank you. So what's the antiderivative of dy over y? Natural log of the absolute value of y equals, how am I going to work that integral out? Substitution, u equals 1 plus x squared du 2x dx. This works out nice. So this becomes the integral of du over u, antiderivative, natural log of the absolute value of 1 plus x squared plus c. I always put the c on the right side. I put the plus c on the side with the x. Okay? Now, this is the function that has this for a derivative. That's what we're always looking for when we solve a differential equation. But this is not the format that mathematicians and or scientists who would be using this type of equation like. So what we're going to do is, well, we're going to get the y by itself. So what can I do to get y by itself here? To both sides. What? Something with e, yes? You don't want to take each side to the power of e. couldn't I make each side the power of e? Make each side the power of e. We call that applying e to both sides. So now, what is e to the natural log of the absolute value of y? It's just y. It's just y. So then we're going to have, where's it at? There it is. We'll talk about that in just a minute. That is an excellent question. That's the question that's the hardest here right now. So Chase's question is, what does e do to c over here? Well, you'll see in just a minute. So I'm going to have e to the natural log of y. Now, why do you just get y? How are e and natural log related? Go ahead, Caitlin, louder. You were right. They are inverses. So what happens? What do inverses do? Cancel each other out. They undo each other, and so you're just left with y equals. Now, here's how we write this. You cannot cancel this e with this natural log because of the plus c. So here's what we have to remember. We have to remember a law, and this is going to apply to so many problems, so please hear this. You'll see it probably more than twice today. But e to the natural log of this plus c, you cannot just cancel the natural log. You must first apply a rule of exponents. And this is a rule that you know, you're just not used to applying it in this direction. Okay, you know that if I had e squared times...
Excuse me, Ms. Kern?
Yes.
Can Emily Bach come up to the main office?
Yeah?
Thank you.
Yeah. She just about got verbally abused, but that's okay. I don't understand why. Don't they think that classes are important? I mean, I don't know. Could someone come down and talk to you? I think they, I know. Okay, so if you were to combine these two, how would you rewrite this so that there's only one e? E to the 2 times e to the x. What do you do with exponents when you multiply? You add the exponents when you multiply. So this would be e to the x plus 2 or 2 plus x power. We're going to use that rule backwards here. So this would be the same as e to the natural log of the absolute value of 1 plus x squared times e to the c. Every time you've got that natural log of something plus c in the exponent of e, what you're going to do before you can cancel the ln is you have to separate it and make e the base of the natural log part and the c part. All right, so now what's e to the natural log of 1 plus x squared? It's 1 plus x squared. And e to the c, here's what we do. We call it one big giant C. Do you know why? It's still just a number. C is a constant. E is a number. E to a number, that power is just another number. Okay, that constant, we just always call it big C, and so I'm going to write it in front of parentheses here. E to the c becomes that one big constant. So this is the function that has that for a derivative. This is the solution to that differential equation. All right, so now we're going to kind of switch gears here. I'm going to give you a word problem. Everybody loves word problems, right? So, word problem. What we want to do is we want to write and solve a differential equation here. Write and solve a differential equation for this. So, here it is. The rate of change of n with respect to s is proportional to 250 minus s. All right, so just so you know, this is a differential equation that we want to solve exactly like the last one. The only thing is we have to write the differential equation and then take the antiderivative. Now, differential equation, you start with a derivative. So the equation you write from here must have like a dy over dx, a ds over dt, a dr over dt. It must have, or like an r prime or an n prime or an s prime or a y prime somewhere in it. Okay, a differential equation is a derivative. So here's how you can tell where it's a derivative. Rate of change. What's a derivative? It's slope. Slope is rate of change. Every time you see rate of change, you know they're referring to a derivative. So this is saying the rate of change of n. What does that mean? That means the derivative of n. So write it the easiest way you know, n prime. There you go. Okay, the rate of change of n with respect to s. Okay, well, even better, instead of writing n prime, couldn't we write dn over ds then? Because they're very specific. They're telling you the variables to use. So the rate of change of n with respect to s. Okay, instead of saying the rate of change of y with respect to x, that would be dy over dx, they're saying the rate of change of n with respect to s. That means the derivative of n with dn over ds. So just so you know, that's what that whole thing, this whole first part gets you that, dn over ds. So I know that dn over ds is, what does is mean? What math symbol does is mean? It means equals, or is proportional to 250 minus s. Okay, now proportional to, here's how you can write a proportional to. Proportional to means a direct multiplication of some number times whatever they give you here. Okay, so this is how you write proportional to. Inversely proportional is like k over 250 minus s. Jointly, they would throw in another variable. It would just be like two things. Jointly with k and y, then it would be something like ky times 250 minus s. So those are basically the three types of relations that this is all stuff from Algebra 2, by the way. Joint variation, inverse variation, proportional, direct variation. And it's just the different ways you write the equations. But these are just for maybe other problems that you run into, just so you have some notes on that. But this is our differential equation, and now we need to solve it. So to solve it, we're going to integrate both sides. And this is where you might get confused. Okay, what are the variables here? N and S. Tell me about the K.